All right, it's recording. All right, here we go. So, on Wednesday, I gave you a sheet on 3G, 3H, and it was the idea of percentages, how you can convert percentages into fractions decimals, and then you use that to solve or apply for percentages of an amount. So you did something like this. And it's going to take a while to scroll up. If you were to find 32% of 20, I said that at this year level, year 7 and 8, you are still learning technique. Technically, if you do it in real life, it's a lot faster with a calculator. But for you guys, we're still training your exercise 3B, multiplying, dividing. So you have to learn to write 32% as a fraction. Of means times, not divide. That's what a lot of students think. And of 20 just means times 20. So really, you're just doing 32 over 100 times 20 is what 32% of 20 means. Okay, so the language when we say 32% of 20, it literally just means 32 out of 100 multiplied to 20. If you've got your fraction skills, then that's what you're going through to get to the answers. You do need exercise 3E to solve the decimals component, okay, or short division to solve the decimals component. So there's quite a bit of skills there that I can see from your exercises. Now, today's lesson is just to finish off. Sometimes you can do percentages, or most times, when you're going shopping, for example, most of the percentages are either something like 20%, 25%, sometimes they'll give you 10% GST included. They might do a 40% sale, and sometimes you might see 70. But what's common about them all is that they're multiples of 5 and 10, which actually makes it a lot easier that you can do it in your head. So we use what we call a unitary method. And this one is ones where, when you're going to buy something in shopping center, instead of whipping out your phone immediately, you can kind of guess roughly how much you're going to pay, right? So I'm going to teach you what we call the unitary method, and you only need 1, 10, and 100. So any multiples of that you can work around. So let's start with 10%, because 10% is the most common one that we work with. 10% we know as a fraction means 10 out of 100. But if you simplify 10 out of 100, what is that? 1 over 10. Same thing as 100%. We already know that is 100 over 100. But 100 over 100 is simplified to 1. So it makes sense that if you said 100% of $20, it's just $20. But then 1% is the ones that we don't usually do, but you can do it if you want to. Yeah. So 1% means 1 out of 100. Right? So how does this help us to do things like 10% of 20? See, 10% of 20, we know that 10% means 10 out of 100, but we know the simplest form is just 1 out of 10. What does of mean again? Times. So this means 1 out of 10 times 20. But when you write 20, which is a whole number, as a fraction, how do you write 20 as a fraction? Ooh, not 20 over 100, because that's 20%. I just want 20, the value of 20 as a fraction. 20 over 1. Now remember, when we're multiplying fractions, top with top, bottom with bottom, but what do you see here is that it actually simplifies to 20 over 10, which means the language, if I asked you to read this, this just means 20 divide 10. So the moment you say 10% of 20, it actually ended up being the same as saying, take 20, divide 10. So if I say 10% of 50, then you do 50, divide 10. If I said do 10% of 1,000, then you're essentially just doing 1,000, divide 10. So for your notes, just to help you remember, when you say 10% of, it's very special because it just means divide 10. That's why you can quickly do it. So if you went and you paid for a meal and it was like $28, and you know they're going to slap GST on top, which is 10%, you can do 10% of 28 very quickly. 10% of 28 just means 28 divided by 10, which gives you 2.8. So you know they're going to slap on $2.80 as part of your, extra. Same thing when you're buying stuff. They usually say if you pay by cash, that's the amount. But if you pay by card, they have a 1.5% surcharge. Technically, you could do a rough estimate using the 1% to kind of estimate how much you're going to pay. Usually, the larger the number, the more dollars you'll worry about. But if you're buying chewing gum, that's $5. That's actually expensive. But let's just say $5 for chewing gum. And you have to pay an extra 1.5% on top. It's very small. But if you bought something that was like a PlayStation, how much do they go for nowadays? All right, 700 and something. 1% of that will actually be more a few dollars. So let's work it out. What's 1%? See, 1% is 1 over 100. If I said find 1% of 20, you can think about it mathematically. You're just saying 1 over 100 of means times 20, but it works out to be that you're really just doing 20 divided by 100. So 1% just means divide by 100. Okay, so with your case there, if it was 700 and something dollars for a PlayStation, 1% is about $7 because you do 700 divided by 100. So $7. Now that might still seem small to you because you're buying a PlayStation. And you're like, oh, extra $7. Yeah, here we go. Use a card. But you can see the difference if you went to $7,000 now. If you bought something that was $7,000, a credit card means an extra $70. If you then went up to $70,000, that's an extra $700. Okay, every time you swipe. So that 1% is small, but depends. The larger the amount, then you can see how much more money you actually have to give. But we did that without a calculator. Yeah. So as part of your notes, you can write now 10% actually means divide 10. 1% means divide 100. And then 100% really you don't really need this one, but it just means divide by 1. Okay? All right. So hence 100% of 20 would just be 20. What about this answer? What's 10% of 20? $2, because 10% means divide by 10. Yeah, so 20 divided by 10 gives you 2. So $2. This one would be $20. And 1% of 20 over here is, what's 20 divided by 100? 0.2. Because remember, when you're dividing, you go back to the left. You're going twice because there's 2 zeros. So the answer is 0.2, which is 20 cents. Okay, so 1% of $20 would be 20 cents. 10% of $20 is $2. And then 100% of 20 is $20. Now, why are these called unitary method? Is because you can use a combination of 10% and 1% to make 20%, 25%, 10, 40, 70. So when you go shopping, those are the most common numbers that you'll see. So here's an example. If you went shopping and you guys want to buy shoes. Back then when I taught at uni high, there was these Yeezys, is that what they're called? Yeah. Yeezy shoes, yeah. And I was a coordinator back then, and I had a bunch of kids that were teasing each other because if you don't have Yeezys, you're considered poor. And so I don't know how expensive those things are, but it just looks like it was a status symbol. But how much, anyone know how much these Yeezys go for? How much? Really? Wow, what's so good about them? All right, so hundreds of bucks, is it? Let's just say 220. Let's say it's $220. If you went into a store and they happen to have a 20% discount, so we know how to do 10%, then doing 20% just means double of that, because 20% is just made up of 10%. True? So if it's $220 and you know that they're going to take off 20%, let's just work out how much 10% is first. What's 10% of 220? 22, because you're just dividing by 10. Yeah, so here, how did I know what 10% of 220 is? 10% just means divide that by 10. So 220 divided by 10, it's just $22. But then if you want 20%, have two of them. So if 10% is 22, another 10% is another 22. Together, how much is that? 44. So quickly in your head, you can kind of roughly estimate. You're like, oh, 220, giving me a 20% discount, I'll lose about 40, 44, roughly. Right? So you can kind of roughly quickly do these calculations because most of the shopping is only under multiples of 10. How do you do the 5? So we can do 10s because 10 plus 10 plus 10, but then how do you get the 5?
10 and 10 getting half of 10.
Yeah, half of 10. See, if I want to know what a 5% was, 5%, if I just know what 10 is, just divide it by 2. But since 10 is $22 already, yeah, it's 11. It's $11. So 25% would be roughly what? 44 plus 11, 55. So you know it's about $220 minus 55, roughly. Don't have to be exact. Yeah. So that's what I mean by unitary method. Do you need this? Not really, but it's just nice when you're going shopping, you can kind of roughly estimate how much is coming out of your pocket, especially nowadays when we're using cards. I think back then with cash, you feel like you're losing money. Now it's a lot easier to just swipe and forget how much you're really spending because the digital part will do it all for you.
Can't you just use a calculator?
You can, but it's just that I don't see a lot of people walking around with, with a phone, they whip it out straight away. They do a calculation. I usually only do that when there's a lot of things I'm buying and there's a lot of decimal places. So if I bought a speaker, it's like $121.98 plus, I'm just making it up right now. And then I went to look at this extra iPod or something and I put it together and they said, oh, you get a 10% discount on each one. And I'm like, oh, okay, then I might pull it out. So it depends on the numbers if it adds up. But usually when you're looking at a t-shirt, I'm just walking by and they're like 20% discount and I quickly look at the label and I see, $45 and I'm like, it's only a few dollars off. I'm like, is it really worthwhile? And I move on. Sometimes I scan on a website when they do, like during this time, they're going autumn sale and they're like, oh, there's a 20% discount. And I look at it, the smaller the value of the price, the 20% isn't that huge. The larger the value, then it's more worthwhile. So those are the kind of things that having an understanding of the mathematics, you can quickly make a better decision. So not all sales are actually sales. Same thing with Coles. If you go to Coles and Woolies, where they say prices are down and they're like 50% off, actually look at the value. When you look at it, the smaller those items are, those percentages don't really mean as much. So that's why it's cool. All right, team, so I'm going to stop the video there. That's just all I wanted to teach you. Unitary method, it's more of a useful life skill. This is a theory skill, and reality is that you can do all that on a calculator. That's the applying. Okay, so applied mathematics, learn how to do it in a calculator, but right now you're practicing theory. Okay? I'll stop there.